Okay, so we're going to start with calculus review. First, we have our function e to the x. E to the x kind of looks like this. It's an exponential function, and so if we plug in 0, e is a number, so e to the 0th power gets 1. So we have our graph crossing 0, 1. And then it's an exponential, so on the negative side, we have 1 over e to the something, and therefore we have a positive number smaller than 1, and on the right side we have e to the positive number, and so it gets exponentially larger. To the left, it gets exponentially smaller, but it never becomes 0. And then we can think about e to the negative x. I'll do that in a different color. E to the negative x would be a reflection across the y-axis, and so it'll look something like that. And so as x approaches infinity, we have our graph, our white graph, approaching 0. And one more, negative e to the negative x will go this way. It'll be a reflection across, do that again. It'll be a reflection across the x-axis. Okay, and then let's review chain rule number 2. So the chain rule is when we differentiate a function f of g of x with respect to x, then the answer is the derivative of f, and then inside f we have g of x multiplied by the derivative of g with respect to x. In another notation, we can write f prime of g of x multiplied by g prime of x. Okay, so because we'll be dealing with the exponential e, let's think about deriving e to the, for example, 4x. Negative 4x also works. Okay, let's try deriving this. Okay, note that the outside function, so f would be, f of something would be e to the something, and the inside function, which goes in here, would be the g, So g of something would be negative 4 times that something. So using chain rule, we have, let me use a different color, this being equal to f prime of g of x multiplied by g prime of x. And note that the derivative of e is just e. And so the first part is going to be just e to the same g of x. So leave g of x alone. And then if we derive g, then we get negative 4 because we have g being negative 4 times something. Okay, so the derivative of g is negative 4. So we have negative 4 being applied here. Okay, and finally, we will go to integration by parts. Okay, integration by parts. Integration by parts comes from the product rule. The product rule is different from the chain rule because instead of having g of f of x, we have f of x times g of x. So instead of deriving this, we are deriving the function on the bottom, which is a multiplication of two functions. Then we'll have df dx multiplied by g of x plus f of x multiplied by dg dx. Okay, and I can have an x here, doesn't matter. Okay, and so if we integrate both sides, then on the left-hand side, the derivative and the integral cancel because they are inverses as shown by the fundamental theorem of calculus. And so we'll have f times g, and I'm ignoring the x's. The x's go in here, but then if we're too lazy to write it, just understand it as f times g is equal to integral, because integral over addition is linear, we'll have integral of f prime g plus f g prime. Okay, and so I can move one of the integrals over to the left-hand side. Then we'll have the integral of f prime g being f of x times g of x. Oh, sorry. It'll be f of x times g of x minus f g prime. Okay, and so the whole purpose of doing integration by parts is because doing this is easier than dealing with our original function on the right. And let's see. And to decide which function is f and which function is g, we have to decide which is easier to integrate. Because f is being integrated, right? We go from f prime on the right-hand side here, and then on the left-hand side we end up with f's, which means we integrated f. And so the order goes like this. We have e and then trig, okay, and then polynomials and logs. For example, e to the x is the easiest to integrate, and then we have sine x, cosine x, and then x to the n for any number n is pretty easy to integrate, and log x is the hardest to integrate. And so our priority for f goes this way. Okay, see you in the next video.